This moon appears like a frozen paradise, smooth, radiant, almost unreal. Beneath that shining crust, however, lies an ocean deeper than any on Earth. And within that vast darkness, something could be stirring. Drifting quietly through space, this world is the most polished object in our solar system. From afar, it seems flawless, like a luminous pearl or a sphere carved from white crystal. It reflects sunlight with such intensity that it glitters like a jewel against the blackness of space. It feels calm, harmless, serene. But that illusion doesn't survive up close. Step onto the surface of Europa, and tranquility vanishes. The ice is not soft or glassy. It forms a brutal landscape of fractured ridges and serrated plains. Ice as hard as stone and sharp as shattered blades. Temperatures plunge to -160 degrees Celsius, cold enough to make metal brittle and snap like dry wood. A spacesuit would stiffen rapidly. Movement would slow, then fail. Yet the cold is not the true danger. The greater mystery and the greater fear lies nearly 15 miles beneath that frozen crust. So why haven't humans set foot on Europa? The answer is simple: Jupiter. Europa orbits within the domain of a giant. Jupiter is not merely large. It dominates with overwhelming gravity and a magnetic field of extraordinary strength. Rotating at tremendous speed, it generates radiation belts that act like a colossal particle accelerator, flinging high-energy particles across space. Europa travels directly through this invisible storm. A landing there would not end well. Electronics would malfunction almost instantly. Instruments would degrade into static. Prolonged exposure would damage living tissue at the genetic level. The surface is bathed in radiation intense enough to make survival nearly impossible. Ironically, this same radiation may contribute to the chemistry that makes life possible. For years, scientists debated what lay beneath Europa's frozen exterior. Was it solid ice all the way through, or something else? Direct drilling through miles of rock-hard ice was beyond our capability. So how did we learn what hides below? In the 1990s, NASA's spacecraft Galileo flew past Europa equipped with a magnetometer, essentially a highly sensitive magnetic field detector. As it passed the moon, the readings fluctuated dramatically. Something inside Europa was responding to Jupiter's magnetic field. Something conductive was present. Solid ice conducts electricity poorly. So does rock. Salt water, however, conducts very well. The measurements pointed toward a single compelling conclusion. Beneath the ice lies a global ocean of salty liquid water, wrapping the entire moon. Estimates suggest it may reach depths of 100 kilometers, 10 times deeper than Earth's Mariana Trench. In total volume, Europa may hold more liquid water than all the oceans on Earth combined. But how can liquid water exist so far from the sun? The answer again is gravity. Europa is not only pulled by Jupiter, but also influenced by neighboring moons like Io and Ganymede. This gravitational tug-of-war stretches and compresses Europa in a continual cycle. The moon flexes rhythmically, and deep within, friction generates heat. That heat keeps the rocky interior warm. It rises upward, preventing the ocean floor from freezing solid. Scientists believe hydrothermal vents may exist there, fissures releasing heat and mineral-rich fluids into the ocean. On Earth, such vents, often called black smokers, teem with life despite total darkness. Wherever we find these systems on our planet, we find organisms thriving around them. Europa's surface is not static. Over millions of years, it fractures and shifts. Oxygen-rich ice from above may gradually sink downward, delivering chemical energy into the ocean below. A slow planetary conveyor belt. Models suggest the water could contain a rich mixture of chemicals, potentially sufficient to support not just microbes, but more complex forms of life. If something does live there, what might it be like? Creatures evolving in perpetual darkness would not rely on sight. They might detect vibrations in the water. They could navigate using sonar-like pulses. Some might generate their own light through bioluminescence. Would they remain microscopic? Or could Europa's lower gravity allow larger forms to develop? We do not yet know. And that uncertainty is both thrilling and unsettling. Science fiction writer Arthur C. Clarke once imagined a warning: "All these worlds are yours, except Europa. Attempt no landing there." Perhaps caution is wise. Some frontiers carry consequences we cannot predict. Yet exploration is part of who we are. At this very moment, NASA's Europa Clipper is traveling toward Jupiter's system. It will use radar to probe the ice shell and analyze plumes of water vapor erupting into space. We stand on the threshold of a discovery that could redefine our understanding of life. If even a single microorganism is found in Europa's ocean, the implications would be profound. It would suggest that life is not a rare cosmic accident, but a common outcome wherever conditions allow. Until that answer arrives, Europa continues its silent orbit, encased in ice, guarding an ocean hidden beneath a frozen skin, waiting for humanity to reach out and uncover what lies below.